Good afternoon, everybody. Today, we'll be dealing with structural patterns and one of the structural pattern called adapter. Structural patterns are design patterns which can be classified again into two types: class structural pattern and object structural pattern. Class structural pattern uses the organization of classes in terms of inheritance, and object structural patterns use the object structure at runtime. The example today we will see for adapter pattern and its variation as a class pattern as well as object pattern. The adapter pattern is the problem in which we want to have the same interface from the application or the client even though the interface changes. So what is the interface of a class? As we know, the interface of a class is all the public operations it is giving as a service. If this public operation, which is the interface of a class, we want to make it same for the client for many different applications, or it should be same in different implementations also, then we go for adapter pattern. The client will expect the same interface to be there even though it changes because of the change in the requirement of that class. So what we go for is adapter. It is also known as wrapper class. The application of this adapter pattern can be used whenever the existing class interface does not match the need. That means whenever the interface is changed but we want to keep it same, we go for adapter pattern. We have two types of adapter pattern. One is class adapter, and as we know, it is object adapter. The solution we will see here in terms of class diagram. Class adapter uses the organization of class. Client here is my application, and we want to use as a client one class called target. It has the interface called request here, but the request implementation has changed. So the concrete class here is adapter, which the client wants to access, and the interface should be same as request even though it is changed. So how to have this? So we come out with one more class called as adoptee, and this adoptee will implement the new part of or whatever is changed part of that interface. Here it is specific request, and this class is uh, as a base class we use, and the adapter will be inheriting from this adoptee. So we design an adoptee class which will use the specific request as a new interface and implement it, and this adoptee class will be the base class of adapter. So adapter inherits from the target as well as adoptee. So client will be accessing adapter. So the adapter interface remains as request. So client will be using request only, but request in turn will call specific request because it can access the specific request operation of adoptee as it is inherited by the adoptee. Here we can see the multiple inheritance structure of the adapter. So request is not changed, but the implementation of request is changed to specific request by the adoptee. This is called as class adopter solution. In the same way, if we go for object adopter for the same, the adoptee will implement a specific request as before in class adopter, but the adopter will be using that means it is depending on this adoptee and uses the specific request method of adoptee by instantiating adoptee in the request method of the adopter. Client uses again from the adopter request only. Adopter is the concrete class which is derived from my target here. So client is using the request as the interface which is not changed, but internally request is creating an object of adoptee which will be calling specific request in the implementation or definition of request. So it is using adoptee object and its method in the interface definition of that method. So in this way, object adopter need not use multiple inheritance. It can just use different adoptees by just using the objectives of adoptee in the interface which is not changed. This is the basic difference between class adopter and object adopter. Class adopter uses here inheritance from the adopter, but here in the object adopter it uses the adoptee methods using the object, calling it at runtime. The example here we will see for an object adopter with a shape as the base class. My drawing editor is the application or the client here, and shape here is my target. The shape is an abstract class. The name is in italics. From this, we derive two adapters here, line as well as text shape. Line is having and text shape is having the two methods, boundary box and create manipulator, two methods which are inherited from the base class shape. Now the interface is bounding box and create manipulator, which should not be changed in the drawing editor. But for a text shape, the bounding box and create manipulator should be changed with respect to text view. The interface will be changed. So it may not be bounding box or it may not be create manipulator. So for this, drawing editor will not change the operation. It makes it as bounding box and create manipulator. But we create a text view adoptee class and implement the get extent method here. And this get extent method will be used in the bounding box operation of the text shape. So we can use here the object of text view as text here, and which will be calling the get extent operation. The create manipulator here will use again here text manipulator, and this text manipulator we can use create manipulator as our pattern, which we call it as factory method, in which we are using how to create different objects. So these two will give us what is and how we can call the adapter pattern and use it in the application. Here it is an example of object adapter because we are calling the changed operation of bounding box using the object text of class text view. This is how we will apply the adapter pattern in the application, where the common operation bounding box create manipulator will not change, even though text shape bounding box will have to be changed to text view. The participants, as we have seen for the adapter pattern, is target, the client, the application which uses the target, adoptee, which is nothing but the class we create for the changed one, and adapter uses the operation of the adoptee to change the interface. Collaborations here, that is how they interact with each other. The client or application call the adapter instant operation, which always remain the same, that is interface remains the same. Even if the interface changes, adapter will call the adoptee to carry the changed operations. But in the class adapter, we use the inheritance and use override for adoptees. But for object, we use the adoptee in such a way that the single adapter work with many adoptees. That means we are creating objects. So we can have many objects created in the interface for different adoptees, and adoptee can be subclassed also by the adapter. The issues in adoptee will be such that the adapter has to take care of the changed interface. How much it is taking care, how much it is uh, taking care, adoptee, depending on that, adapter can change. And if the adoptee cannot change much, then the adapter has to change totally the interface. And pluggable interfaces is whenever I have many interfaces which may be changed, then we have to create many adoptees at a time. And the adapter also such that two-way adapter in which we can make use of adapter to adoptee, and adoptee can also use adapter. In the implementation of class adapter in C++, the multiple inheritance can be used in such a way that adapter inherits publicly from the target and privately from the adoptee. And for pluggable adapters, that means whenever we have many changes, whenever we have many adoptees as well as adapters, we can use abstract operation, delegation of objects. That means different adoptee in terms of object adapter, and parameterized objects like templates can be used for making use of or resolving the pluggable adapters whenever there are many adapters and adoptees involved. The related patterns can be proxy, which we are studying also, where proxy pattern uses a class to delegate the operation, actual operation, to a real object. In adapter, and which is having class and object adapter, which is mostly useful when we need the application should not change the interface, even though the interface has to change because of different implementations. Thank you.